Alright, you are welcome again. Today, I want us to consider a very important topic, which is how to form quadratic equation. You are solving and you are seeing different types and different kinds of quadratic equation. Haven't it occurred to your mind to ask, how is this quadratic equation being formed? So today we're going to show you how this quadratic equation is being formed. This lesson, you can see a similar question in JAM question, WAEC, NECO, or any other platform where you'll be asked to find a quadratic equation whose root is given. You get it? Yes. I want us to see the formation of quadratic equation whose roots are given. How to form quadratic equation with any given root. You get it? Now let's go. We are going to see examples from this video. Let's see, for instance, find a quadratic equation whose roots are 7 and minus 2. That is number 1. And then number 2, find a quadratic equation whose roots are 2 and 1 all over 3. Then number 3, find the quadratic equation with rational coefficient which has 1 all over 3 plus 2 root 2 as a root. Number 4, find a quadratic equation with real coefficient which has 2 minus I as a root. Okay, yes, I want us to use these examples, these 4, to show you how to form a quadratic equation. Please, I want you to pay attention to this lesson and watch this to the end, most especially number 3 and number 4. Number 3 requires a special logic, and also number 4. Please, I want you to watch this to the end so that you will get the true basic or principle of how to form quadratic equation. Now let's go. I want to show you a very simple formula that you can use to form any quadratic equation. The formula is this: x squared minus open bracket sum of the roots close bracket x plus product of the roots equal to 0. Hello, I want you to remember this. X squared minus open bracket sum of the roots close bracket x plus product of the roots equal to 0. You get it? I want to simplify it for you. I want to make it to be very simple for you. I can simply say x squared minus this sum of the root, let's use a letter s, then xx plus product of the root, let's use p as a letter, equal to 0. So for us to form any quadratic equation, we can simply say that the formula we can use is x squared minus sx plus p equal to 0. Hello, we can use x squared minus sx plus p equal to 0, where we say that s is sum of the root and then p is the product of the root. All right? Yes. Now let's go. Let's take the first one. The first one says find a quadratic equation whose roots are 7 and minus 2. And then we have the root here to be 7 and minus 2. Now let's go. We have our formula to be x squared minus sx plus p equal to 0. Now let's fix it here. We're going to have x squared minus, let's open the bracket, our root now, the sum of the root. We have 7 plus, open bracket, minus 2, close bracket, x, plus the product now. We have 7 times minus 2. That is the product of the root, close the bracket, equal to 0. Now let's go. We have x squared minus, in this first bracket, we say 7 plus, we have minus 2 in the bracket. So we say plus times minus 2 is going to give us minus 2. Then when we say 7 minus 2 is going to give us 5. Okay, so we're going to have x squared minus 5 in bracket. Let's put x outside plus. Now when we say 7 times minus 2 is going to give us minus 14. Let's put it in bracket, equal to 0. All right, good. Now let's go. We have x squared. So we're going to have here minus 5x. We'll say plus times minus 14 is going to give us minus 14 equal to 0. So therefore, the quadratic equation whose roots are 7 and minus 2 is giving us x squared and minus 5x minus 14 equal to 0. Please, I want you to solve this. Solve this quadratic equation and then see what is going to give you. You discover that your final answer is going to give you 7 and minus 2. You can use any method or just use a quadratic method. All right, yes. Now let's take the second example. We have find the quadratic equation whose roots are 2 and 1 all over 3. Okay, so here we have the root to be 2 and 1 all over 3. Let's use our formula. We have x squared minus xx plus p equal to 0. Okay, now let's go. We're going to have x squared minus open bracket. Now the sum, we have 2 plus 1 all over 3, close the bracket, x plus the product. Now we have 2 times 1 all over 3 in bracket equal to 0. Okay, now let's go. We have x squared minus, when you say 2 plus 1 all over 3, when you solve this, it's going to give you 7 all over 3. Is that true? Yes. When you say 2 plus 1 all over 3, it's going to give you 7 all over 3. Let's put it in bracket. X plus, when you say 2 times 1 all over 3, it's going to give you 2 all over 3 equal to 0. Okay, good. Now let's go. We're going to have x squared minus, in this place, let's remove this bracket. We're going to have minus 7x all over 3 plus 2 all over 3 equal to 0. Yes, you know, we can see that we are having fraction here. I want us to remove this fraction. Pay attention to what you're going to do. We're going to multiply 2 by 3. We're going to multiply 2 by 3. Thereby, we'll eliminate the fraction. Okay, so that means we're going to have x squared times 3 minus 7x all over 3 times 3 plus 2 all over 3 times 3 equal to 0 times 3. Okay, so in this first place, we're going to have x squared times 3 is going to give us 3x squared minus 7x all over 3 times 3. You know, this 3 will cancel 3. We'll be left with 7x plus 2 all over 3 times 3. This 3 will cancel 3. We're going to be left with 2 equal to 0 times 3 is equal to 0. So therefore, we're going to have 3x squared minus 7x plus 2 equal to 0. Hello. So the quadratic equation whose roots are 2 and 1 all over 3, the quadratic equation gives us 3x squared minus 7x plus 2 equal to 0. All right, yes. Let's take the third question. You get it? All right, yes. The third question says find a quadratic equation with rational coefficients which has 1 all over 3 plus 2 root 2 as a root. All right, yes. Now let's go. You know, we said that the root here is 1 all over 3 plus 2 root 2. You get it? Now look at this very well. We are not going to use this to solve. I want us to rationalize this. I want us to remove this 2 root 2 here. I want us to rationalize this. I want us to make it to be very simple. Okay, now for us to rationalize, pay attention. We are going to multiply the numerator and the denominator by the conjugate of the denominator. That is rationalization. Hello, you know, if you have been following us in our consequent lessons, we have done similar things like this. Okay, please pay attention. We want to remove these 2 root 2. So in so doing, we are going to multiply the numerator and the denominator by the conjugate of the denominator. Hello. Now let me show you. The conjugate, we have the denominator to be 3 plus 2 root 2. So the conjugate of it is going to give us 3 minus 2 root 2. So let's go. We're going to have 1 all over 3 plus 2 root 2 times 3 minus 2 root 2 all over 3 minus 2 root 2. You get it? Yes, this is called rationalization. Then you discover that 3 minus 2 root 2 all over 3 minus 2 root 2 is going to give you what? 1. So this 1 times our expression, it remains the same. Is that true? That means we have not done anything bad. All right? Good. So now let's go. Let's multiply. 1 times 3 minus 2 root 2 is going to give us 3 minus 2 root 2 all over. In this denominator, let's just pick the two of them, the two expressions, and put it in brackets separately. So that means we're going to have 3 plus 2 root 2 in bracket times 3 minus 2 root 2 in bracket. All right? Yes, let's go. Now let's multiply the denominator properly. We're going to say 3 times 3 in the next bracket is going to give us 9. And then 3 times minus 2 root 2 in the next bracket is going to give us minus 6 root 2. And then plus 2 root 2 in the first bracket multiplied by 3 in the next bracket is going to give us plus 6 root 2. And then plus 2 root 2 multiplied by minus 2 root 2 in the next bracket is going to give us minus 8. Hello. It's going to give us minus 8. Now let's go. We have 3 minus 2 root 2 all over 9 minus 6 root 2 plus 6 root 2 minus 8. You get it? Yes. Now here we have minus 6 root 2 plus 6 root 2. So this will cancel each other. Okay? So we'll be left with 9 minus 8. So here we are having 3 minus 2 root 2 all over 9 minus 8. So 9 minus 8 is equal to 1. So that means we're having 3 minus 2 root 2 all over 1. So 3 minus 2 root 2 all over 1 is the same as 3 minus 2 root 2. Okay? So after rationalization, we come up with a value which is 3 minus 2 root 2. Now you have to take note that a quadratic with rational coefficient, the root occurs in conjugate pairs. Hello. You are to take note that a quadratic with rational coefficient, the roots occur in conjugate pairs. So here, the root that we have here is 3 minus 2 root 2. So we are to note that this 3 minus 2 root 2, it usually occurs in conjugate pairs. So that means the two conjugate pairs is going to give us 3 minus 2 root 2, and the conjugate of it is going to give us 3 plus 2 root 2. Hello. So the root that we are having here is 3 minus 2 root 2 and 3 plus 2 root 2. All right, let's apply a formula here. We have x squared minus sx plus p equal to 0. Okay, now here let's find the sum of the roots. So the sum of the root is going to give us, we have 3 minus 2 root 2 in bracket plus 3 plus 2 root 2. Hello. So you know we have the two conjugate pairs to be 3 minus 2 root 2 and 3 plus 2 root 2. Okay, so this is just the conjugate of each other. All right, so the sum of it is going to give us 3 minus 2 root 2 in bracket plus 3 plus 2 root 2. Okay, here let's remove the bracket. So we're going to have 3 minus 2 root 2 plus 3 plus 2 root 2. Okay, so here minus 2 root 2 plus 2 root 2 we cancel. So minus 2 root 2 plus 2 root 2 is equal to 0. Okay, so we have 3 plus 3 equal to 6. So therefore the sum of the root is equal to 6. Let's also find the product of the roots. So the product of the root is going to give us 3 minus 2 root 2 in bracket times 3 plus 2 root 2 in bracket. Okay, now let's multiply. 3 times 3 in the next bracket is going to give us 9, and then 3 times 2 root 2 in the next bracket is going to give us plus 6 root 2. Then minus 2 root 2 times 3 in the next bracket is going to give us minus 6 root 2. And then minus 2 root 2 times plus 2 root 2 in the next bracket is going to give us minus 8. Okay, yes. Now, plus 6 root 2 minus 6 root 2 equal to 0. So we'll be left with 9 minus 8. So 9 minus 8 is equal to 1. So therefore here, the product of the root is equal to 1. So let's apply the formula properly. So we're going to have x squared minus sx plus p equal to 0. So here we have our s to be 6 and then our p to be 1. So therefore we're going to have x squared minus 6x plus 1 equal to 0. Hello. So here we just discovered that the quadratic equation with rational coefficient which has 1 all over 3 plus 2 root 2 as a root is having the quadratic equation x squared minus 6x plus 1 equal to 0. I want you to solve this quadratic equation and then find out what it's going to give you. Okay, now let's go. Let's take the last question. Okay, let's take the last question. The last question says, find a quadratic equation with real coefficient which has 2 minus I as a root. All right, yes, you know, we have the root to be 2 minus I. Now, you discover that in complex number, I is the same as square root of minus 1. All right, yeah, if you have been following us in a complex number, we have treated so many things like this. All right, please, I want you to watch some of our videos on complex numbers. All right, good. Now let's go. Here I want you to note that a quadratic with real coefficient imaginary root occurs in conjugate pairs. I want you to note that a quadratic with real coefficient imaginary roots occurs in conjugate pairs. That is to say that this 2 minus I, it usually occurs in conjugate pairs. So the conjugate pairs of these 2 minus I is going to give us 2 minus I. So the conjugate of it is going to give us 2 plus I. Hello. 2 minus I. The conjugate of this 2 minus I is going to give us 2 plus I. So these 2 minus I and 2 plus I are the root of this quadratic equation that we're going to find. Okay, now let's go. Applying the formula here, we have x squared minus sx plus p equal to 0. Here, let's find our s, which is the sum of the roots. So the sum of the roots is going to give us 2 minus I in bracket plus 2 plus I in bracket. Let's open this bracket. We are going to simply have 2 minus I plus 2 plus I. You get it? Yes. So when you say 2 plus 2 is equal to 4, and then minus I plus I is equal to 0. So the sum of the roots is equal to 4. Let's also find the product of the root. So we have 2 minus I times 2 plus I. Let's put them in bracket, okay? So 2 times 2 in the next bracket is equal to 4. And then 2 times I in the next bracket is equal to 2I. So we have plus 2I. Then minus I times 2 in the next bracket is going to give us minus 2I. Then minus I times I in the next bracket is going to give us minus I squared. All right, good. So here we have 4 plus 2I minus 2I minus I squared. So you know that I squared is the same as minus 1. Is that true? Yes. So we have plus 2I minus 2I equal to 0. Okay, so we have minus I squared. So I squared is the same as minus 1. So we have 4 minus in bracket minus 1. So minus 1 is going to give us plus 1. So 4 plus 1 is equal to 5. Okay, so therefore we have the product of the root to be 5. Okay, now let's go. Let's apply the formula properly here. So we're going to have x squared minus sx plus p equal to 0. Okay, so we have our s to be 4 and then our p to be 5. So therefore our quadratic equation is going to give us x squared minus 4x plus 5 equal to 0. X squared minus 4x plus 5 equal to 0. Yes, I want you to solve this quadratic equation and find out what it's going to give you. Thank you very much for watching. Please keep practicing. Please, if you are new to our channel, please, I want you to subscribe. Subscription is free. Keep watching, share, and like our videos. All right. Thank you very much. See you next time.